Now then the next part here we have got the techniques that use limited statistical and structural analysis. This is a mashup, a search engine, sort of a search engine that uses Yahoo's term extraction facility. For example, if we enter the search term here, oil price, what it does is it organizes the search results into a cluster of tags here. For example, here, oil price. Immediately we know that, okay, this has got something to do with barrel, oil prices, crude oil and stuff like that. It is actually quite amazing how this simple use of Yahoo term extraction services can help to enhance the navigatability and interpretability of search results. And then as you can see here, once I click on that crude oil tag there, then the list of news or search results associated with that term, they are listed down here. Now, overall, essentially, while it may appear to be very amazing, actually the basic strategy is actually a no-brainer. It involves segmentation first, second, tokenization, and third, simple statistical co-occurrence. Let's have a look here. So, assuming that we've got a simple text snippet here, we can actually fit this sentence here into the term extraction facility by Yahoo and obtain a list of terms, important key terms from this sentence there. So as you can see, oil search here corresponds to only part of this named entity. So oil search is supposed to be oil search limited, or the extended version, gas producer oil search limited, and not merely oil search. And then for gas producer here, we've got over here, and then net profit here, and oil prices here, Australia here. And as you can see, other important key terms that describes the essence of this piece of information are not included. For example, weaker demand, fiscal year 2009, lower oil prices, not just oil prices, percent drop and stuff like that, they are not included. Yahoo's term extraction facility actually needs all those things up because they base merely on, this technique is based merely on the segmentation, simple segmentation, tokenization, and statistical co-occurrence. Now, Google too is jumping on the bandwagon of providing more intelligent search results or navigation of their news. At the right-hand corner here, at the bottom here, you can see it actually provides a list of named entities, institutions, organizations, people that occur in today's news here. So this is Google's way of providing, assisting the users in actually locating the key contents of the news here without actually clicking on each of them and reading. Now, the problems with these existing approaches, they are first, as we mentioned, manual approaches, they rely on human, and we know that they are biased, subjective, inconsistent, and the process is very time-consuming. Second, as for those automated systems, they require extensive background knowledge. And current systems, they are mostly dependent on static form of background knowledge, for example, collection of text, semantic lexicon like wordnet and stuff like that. Those are all static. They cannot grow with time. Then besides being static, current systems also are very dependent on statistical techniques only, and also predefined rules and patterns. And static knowledge, they are inadequate in terms of diversity and redundancy in language processing. For example, let's say the text collections created during the Shakespearean era, using English, the early modern English, like thou shalt not bear false witness and stuff like that, very archaic, I know. Those kind of text collections are unable to deal with the requirements of processing languages that contain words like, new phrases like metrosexual, iPod, Xbox, hip-hop, and stuff like that. And another example, let's say the general semantic lexicon wordnet. Such a static resource is also unable to deal with, let's say, the processing of medical text that contains phrases like myocardial infarction, which is essentially a fancy term for a medical term for heart attack. The fifth problem. Currently, there's no study on the systematic use of dynamic web data as background knowledge to overcome the problem of static data for all phases of ontology learning. And lastly, current applications, they focus on collection level abstractions, or in other words, the grouping of web pages and providing metadata at that level only. Let's look at this example. If you recall from our just 2 or 3 slides the previous 2 or 3 slides, if you recall, this is provided by Google to assist the users in navigating through or obtaining an overall picture of who are involved or what are involved in the main news today. So if I were to click on that phrase there, snow leopard, I will still be provided with a long, very, very long list of about 5,000 news articles. What does this mean? At the end of the day, the end users will actually have to go through, click, read, no, not interested, click, read, what I'm looking for, no, click, read, interested, no, sorry, move on, for 5,000 news articles, so it is not very smart. As you can see here, all we can rely on if we refuse to click and read because of the broadband fees, I'm not sure, we have to rely on these very inadequate text summaries. Read, no, I guess not, read, no, I guess not, and so on and so forth. So, in other words, there are essentially no document level abstractions. In other words, I cannot actually preview the content, the important concepts, components in this news article without actually getting through the very inadequate text summaries or clicking on it and reading by myself. So, those are the 6 problems with the existing approaches. So now my approach. But before that, we recap. Just in case you guys are falling asleep. Why is automatic multi-level abstractions of text important? First, for annotating web pages with metadata to achieve the semantic web, if you recall. Secondly, for improving information findability, interpretability on the web. Second. Okay, now, my solution involves the research and development of ontology learning techniques for creating text abstractions in the form of term clouds, just like the text clouds, and lightweight ontologies through the automatic discovery of terms, concepts, and very coarse-grained relations. Now, my hypothesis is that the process of ontology learning from text across a wide range of domains, currently my focus are economics, technology, and medicine,